Hi, dear students. Welcome to part 3 of our project series on time series analysis Python project using JupyterLab and our paper forecasting daily customer for restaurant. Today we will wind up the project and include three more models: LSTM, random forest, linear regressions, and finds the effects of these models and compare them with the XGBoost. We will also conclude and provide you the future works which can help to improve the overall results. So please keep watching.
We just import all the important packages, and then we created a data frame. We start reading the data frame from the location. Then we visualize the data. Now we have gathered all the information, all the steps we did it, and put them in the proper functions here. So in first two functions, we visualize the data and we read the data from PD to the CSV, and then we just make feature formation. So we add different categories of the feature. After that, then I just call all of them in one place that we can have the df. So we can see now df equals to, we can say, so we have complete df package with df dot info. You can see we have total of 1418 rows with 13 columns. So almost 13 columns we have. And I want to do one thing here with this df, that we can save this, that we don't need to recalculate everything to job lib in order to process it faster. Then we don't need to calculate again and again. For that, we need to import job lib. So for that, we need to dump job lib dot dump. What we are going to dump is location. For example, we have a pickle file, pickle underscore file, and we can name it data dot job lib. Then we can call this as a df, and we can say job lib dot load and the same location. So we can copy paste this location. Let's check df. So df is missing. What we are going to dump first. Yeah. Now we can add best features, top 4 features. So keep in mind that we have this previous results. Now let's improve the result and change the features. So we can copy this code and we can paste here in part 3. The results said that we are going to compare from the previous part. Now these are the results, and let's dot columns. So we need previous day customers from our list. Yes, as a first. And what was the second one? Second one was day before holiday. So previous day customer first feature. Next we have a day before holiday, exponential smoothing, rolling mean. So we will use 4. Let's check first. So next we have day before holiday. Yeah, next highest. And you can say double here. And then we use exponential smoothing, third one, And fourth one, we use rolling means, yeah, rolling mean. Yeah. Now let's run the XGBoost model, trend test, and predict the values. Keep in mind we have these values. Okay, let's run. Now we can clearly see the difference in the results. So we can see around 10 percentage improvement. So lower MAE 88, previously MAE was 97.69. But you can notice that RMSE increased 124 and MSE also increased a bit. So there's a certain change. So let's try with the three features only. Let me check with the score with the three features. 88 and 123, but I think so. This is okay with the 4. And let me test with adding other features, like maybe we can add one more feature is holiday and day of week. Let me check is holiday. But it increases MAE and also RMSE and MSE. So is holiday is making our result worse. So better to keep these 4. However, these 4 improve the overall result. Now MAE is 88 and RMSE is 124. Let's see more operations, what we can do in next slide.
We are going to implement a new model called random forest. So we already checked XGBoost performance. Now let's move to the random forest. We need to replace this model equals to XGBoost replaced by the random forest. So now let's move to the code for the random forest. For the random forest, we need, for example, we need to define a random forest model. We can equals to a random forest regression. Now we need n underscore estimator. We will use 500 and max underscore depth equals to none. Max depth equals to none. Then we need min simple minimum sample spelled equals to 2. Then we need min simple leaf min underscores sample leaf equals to 1, and the max feature equals to score. I will explain these all and the next slide. Bootstrap equals to true, and n underscore jobs equals to -1, and random state same 42. And we need to return model. Let's replace this model thing from the previous one. Yes, this one. This one goes down now. Model equals to this one. Let's check. Yeah, we have improved the result 83. Before it was 88, not 88 with the good features. Earlier we had 97 MAE and 121. Let's compare this result with the current results. So we can see clear differences. However, MSE increased and RMSE also increased, but MAE improved a lot. It is 83 now, which is good. Let's compare random forest with XGBoost. Random forest builds on many trees independently and in parallel, while XGBoost builds trees sequentially, each correcting errors of the previous ones. The average prediction to reduce variance, making it less prone to overfitting. Often achieve higher accuracy by focusing on difficult cases. Robust to noise and outlier, simpler to tune for a good baseline. More prone to overfitting if not carefully tuned. So random forest is more prone to the no, XGBoost is more prone to the overfitting and carefully, if not carefully tuned, require more hyperparameters and also requires extensive feature engineering for time series data. Yes, and for the random forest, it requires extensive feature engineering, legs feature, sequentiality, and holidays. Legs, we saw that we have year, month, and baseline features. So let's move to our features that we choose for the this one, and let's try to run the same code but changing the model only. So let me go through and we just take this model from here, replace XGBoost. Let's check the result now with the best features, four best features. Now we have 84 and not improved. Yeah. Let's take one more thing. Customers greater than 50 per outliers. We find that we have outliers in our data, which is like below 50 is considered to be the best outlier. So let's check DF with the DF customers. Uh, this one and here. Yeah, although it increases this MA and doesn't work perfectly. So let's move to another model. Next, we move to the linear regression. So linear regression, we can import linear regression from scalar dot linear underscore model. So let's define the linear regression function now. So we can say define linear regression underscore forecast. So we can say linear regression model equals to linear regression and nothing, just return the model LR underscore model. And let's try to run the same code with the model.fit and we get results and feature the same. So linear regression forecast. Okay, let's check the result. So we have quite improved result from 83. Yeah, similar to random forest. Likewise, let's check the result of random forest. Yeah, even there's just only 72 and 82. But you can see in random forest case, RMSE is 109 and MSE was 12,000, but here is 13,000. So little improvement from the random forest in MAE case. Let's do it with this program. Let's check. And we have now this linear regression model. Not random forest, but the linear regression. Yeah, 87. Let's check with the same program. Yeah, 87. Doesn't work, but this is the better version. So we cover linear regression, random forest, XGBoost, and last we will check LSTM and then finish this video. The last model, LSTM model. This is neural network model that we need DF target features and train test spelled function that we already use in previous programs. So now we need, for example, a data underscore train, and same way we need is for data underscore test. For train, we need to train customers dot values dot reshape -1, comma 1. Same thing we need here for the test. Only change the test. Okay, let me check data dot shape 0. Yeah. Yeah, we have 14, 18 rows total. So let's check how many rows in train and test. DF data underscore train dot shape 0 numpy array, and also test now. Yeah, we need to print this one and this one and this one, this one, and this one, and this one. Yeah. So we have total 1418 rows in the data. Then for the training, it is like 80% 1134, and for testing 284 rows. So let's check data underscore train. So we have rows, first initial 80% of the data, and for the test, we have the same last 20% of the data. A scalar equals to min max scalar. We already imported that one, and we can say data underscore train underscore normalize equals to scalar dot fit dot transform data train. Data underscore train which we created last time. Then we can say data paste normalized. We can copy paste this one and equals to this one. And we need to change the data from here to paste. Then timestamp needs to be 3 steps equals to 3. Okay, so there's one issue. Scalar.fit underscore transform, and there's no fit here, only transform. Let's run this one and let's move to next level now. We can say x underscore train, comma, y underscore train equals to create a function dataset that requires data normalize this one, train normalize, and other thing we need is timestamp. Then we can say x underscore train equals to np dot reshape x underscore train, comma, x underscore train dot shape. We need 0 here, comma, x underscore train dot shape 1, comma, 1. Okay. Okay, so let's create data set function. So we can say define create data set. We need a data set, comma, time underscore step equals to 1. We need both x and y. X comma y equals to dictionary. So next part, I in range length dataset minus time is temp and time is step, sorry, minus time step steps. And we can define a as a variable. A equals to data set I colon I plus time steps comma 0. Then next we say that x dot append that x and y. Yeah, x is bigger here. X should be bigger. X dot append a and y dot append dataset I plus time steps 0 Then we close this one and this one. Okay, and need to return what? Np dot array x comma np dot array y. Okay, so next we can say LSTM underscore model equals to sequence null. And LSTM underscore model, LSTM model, LSTM dot 8, we can say LSTM unit equals to 50, input shape we need equals to x shape, x train, sorry, x train dot shape 1, comma 1 after 0. Okay, so make sure we close all the brackets. We open 3, so we close 3. You can say LSTM underscore model dot 8. We need to add dense levels, so we can say 1. And after that, we need LSTM model dot compile. LSTM underscore model dot compile. What we need to compile, optimize equals to Adam and loss equals to mean square error. Mean square error. And then we can say LSTM model dot fit x train y train epoches equals to 50. Then we need h underscore size equals to 1, comma verbose equals to 0. Okay, so we need now x test, comma y underscore test equals to, we can copy these both lines from here. Sorry, this one. First, when you change from train to twist, and yeah, same way, we need to copy this whole line. Say y x y train equals to x test train x test equals to, and x underscore test x test test. Okay, the LSTM prediction model, you can say LSTM underscore prediction score predictions, just one variable. And LSTM underscore model dot prediction predict. Make sure you write this test. And next we need the same LSTM underscore predictions equals to scalar dot inverse transform underscore transform LSTM prediction. After that, we need LSTM RMSE equals to NP dot squared. Then we need mean squared error. We need data paste time stamp time steps comma LSTM score predictions double. Then we can say LSTM MSE equals to mean squared error mean squared error. Then we need data. Let's go paste time. Let's go steps. Time steps and then colon. You can say and LSTM predictions. I found the problem here is like prediction is not there, predict is there. So let me run a few more things. MA remaining LSTM. Let's go. MA equals to, this is the same. We need to copy this one and paste here, but need to change absolute. Let's run this again. Just need to print all those results. So we can say LSTM RMSE print LSM LSTM MSE print LSTM MAE. So let's take the results. So we got a very good result with LSTM now. 80 is MAE and 13,150 MSE is 115. Quite good. Well done. LSTM performed very well. Time to conclude this part 3 and this Python time series analysis project series. So you can further improve the result by improving the features. You can add more features like weather data, maybe the city where the restaurant is located. We used Turku data when we were using this paper. And then the elevator data, how many people are using elevator coming to top floor. So there are elevators in the building where the restaurant was located. And then we have this menu food data features. You can include vegetarian, meat, non-vegetarian, and lactose, and any allergies. And also you can include price for the dishes. We will learn this outlier and anomaly detection in lecture 3, part 2, where we will discuss in more detail about anomalies, how anomalies are affecting the result. For now, we are completing this series.